Ladies and gentlemen, welcome back to yet another edition today of Ask That. We are live here at that conference, and with me today I have Chris, head of developer experience, right?
Correct.
Of Misty Robots. So we're going to have, this is an interesting time. We just had a conversation about with Particle about their development boards and all that, and just IoT in general, geeking out. So Chris, welcome.
Thank you.
Thank you for being here. Thank you for sponsoring. To get started, let's do just a quick introduction. So who is Chris? Who is Misty?
So I'm Chris Meyer. I'm the head of developer experience at Misty Robotics. The purpose of Misty is really trying to drive the needle with the adoption of consumer robotics.
Okay.
Right? So if you look historically at the computer industry, you saw the same kind of adoption curve that we're starting to see with robotics. You had early adopters and you had industry, right?
Okay.
Heavy industry and that sort of thing, and then research.
Sure.
So if you wanted to go today and try to build a robot, all right, you go and or use a robot. You'd have to go and buy a hobby platform, build it, and then have maybe 3 months of work with a control system to get it to drive straight.
Sure, sure.
Or I mean, you might be better than
sure.
I am, but or you spend a non-trivial amount of money on something that is putting you into a certain type of environment, and you have to learn the ins and outs of that environment.
Sure, sure.
So what Misty's trying to do is give anybody with a modicum of programming ability to meaningfully interact with a robot.
Okay.
So, I mentioned computers and the adoption there. It took 3 years between the release of the Apple II and then the release of VisiCalc. So who were the primary users of the early computers? It was early adopters and programmers.
Yep.
And so then you saw the adoption of personal computers and then the rise of that entire industry.
Okay.
So we're trying to enable people to figure out what are those use cases for robotics in their home and office.
Okay.
Right? Everybody has a different perspective.
Sure.
We're trying to enable them to figure out what those things are.
Sure, sure. Let's put a definition around robotics then.
Okay.
So, because that's out there, and we're in the Midwest, so you have a lot of manufacturing and things that go there. What does robotics mean in your world?
Okay. And now, that's a very broad question.
I know.
Right? Because robotics means very, very different things.
Right.
So, so we came from Sphero.
Okay.
The
little ball.
The little ball, the little BB-8.
Yep.
Right? So Sphero sold 3 million robots.
Yep.
Those were robots.
Yep.
Our definition is a little bit tighter.
Okay.
In that a robot to us is something that you can, program and control.
Okay.
But what we're trying to get towards is more autonomy, right?
Okay.
So I don't manually control the actions of this robot.
Okay.
So we're trying to enable people to start to think about, like, what does that look like?
Sure.
So figuring out what that actually means.
Sure, sure. So this is less about less about like my robot needs an arm and a pivot, and this is more about here's a platform that already does something. How does software then play in it?
Loosely.
Okay.
I mean, and I'm kind of dancing a little bit because I even personally don't have a very tight definition of what a robot is. We actually have debates like, is an RC car a robot?
Totally.
Kind of.
Absolutely.
Yeah.
Absolutely. Yep.
Or is if I'm manually controlling it, does that make it a remote control machine or is that a robot?
Fair.
So these
I like
types
that.
of debates are very they quickly get philosophical and religious in nature.
Yep. Especially with AI and everything that's here today.
And that's a very fascinating subject in and of itself.
Right. So, but where do you so you're trying to enable folks to think in this new paradigm, but are we strictly focused on the software side or also teaching to build? Because the engineering side of robots is completely different than the software driving side.
I wish I should have grabbed the Misty. It's sitting right over there at the table, but maybe I'll run back and grab it here in a second. With Misty, our focus and my focus in particular is trying to make sure that the development tools and the cognitive dissonance between the way that people think that they want to program a robot and the way that they actually program a robot is as small as possible.
Sure.
So I mentioned like hobby robots.
Yep.
So if I pick up and I'm like, okay, I wanna build a robot that goes from point A to point B, and looks for my face and plays a playlist.
Yep.
Like my Spotify playlist. The way that I actually do that today is I have write a control system. I have to drive motor commands. I have to not hit things. And then I have to get all these little components.
Yep.
So the origination of the idea that I want to build and the way that I actually build it is very different.
Yep.
So we want to be like, okay, I want to go from point A to point B. I want to look for a face, and I want to play a playlist. That gives very few lines of code on what we're trying to enable people to do. So on the software side, that's what we're trying to do. On the hardware side, I mean, we love makers and that whole movement. And 3D printers enable a lot of like rapid prototyping.
Yeah, totally.
So on Misty 2, we have an Arduino backpack.
Okay.
So you can take the project, you know, if you have a temperature sensor or something like that, do whatever pre-processing on an Arduino and put it on the backpack, and now you have a mobile sensor that Misty can then use in her skills.
Sure. Yeah, so you have this, you're trying to enable kind of a thought process. That's not necessarily a business model by any stretch.
Nope.
So then where?
So as far as the business side of things go, we look at robots are coming one way or another. Like, I think that's pretty clear for a lot of people. The question is, when is it going to be broadly adopted? So we look at how can we expand this market. And so our theory is that if you give people, especially programmers, the ability to figure out what those use cases are, the market's going to grow when you have people look at an application and say, oh, that's valuable. So we want to facilitate entrepreneurs to be able to utilize a robot in their area, in their domain of expertise. Same thing for hardware folks. Like, most mechanical engineers will build a beautiful mechanical system, but then you have the electromechanical concerns of the manipulation, and then you have the other element of, how do I know I can grasp something? You know, and trying to enable people very quickly to figure out, like, I want to work in the area that is valuable to me and not in the area that I don't have expertise. You know, so that's how we're trying to move the needle ahead.
And I bring that up because I've been playing in the IoT space for a long time, and I have projects that are kind of on this precipice of, you know, we've built a thing on a development platform. It controls the radon sensors and all this good enough.
Oh, excellent.
Now
we should talk after this.
That we should. then there's the, okay, now it needs to be manufactured as a product, and going from a development platform to a, you know, sealed unit and all of that that can ship to a customer is a much
daunting.
It is. Yes. It's very daunting, although feasible, right? And so as you're talking, you know, I'm trying to picture the scale being so much grander because, you know, we're not driving BB-8s around, you know, other than for toy type things. But, you know, if you came up with a good thing, now you're talking about industry level type stuff that's happening. And that scale is exponentially more than, you know, me trying to put out a smaller IoT thing.
Exactly. No, and we are very aware of that. So internally, we've kind of set ourselves up in such a way that when there is, like, let's say that your radon sensor, you're like, I've got 1,000 customers all lined up and ready to go.
That'd be fantastic. That would be a great problem.
I mean, we have the entire process set up to where we can manufacture a lot of units very quickly. We know that when we deliberately put a lot of engineering effort into Misty 2 as a platform to facilitate the extension of certain things. This is where the backpack comes in, right? So if you don't want to mess with these other things, or if, you know, potentially you want to have you know, an outdoor ruggedized version, you know, then we're definitely open to some of those conversations. But in order for you to get those 1,000 customers, you have to have a pretty compelling proof of concept that it's going to work. So
and a platform of which you can kind of build on to get to that point.
And so you know, we're hoping that that's the case. That you figured out and have this like wide market.
What does it look like I mean, for those who don't know, I mean, what does it look like to program a robot? Robot in its loosest sense. Right?
So today we have a few different methods of programming, at least Misty. Do you want me to speak broadly on the market in general?
No, I mean, you speak to Misty. I mean, I think for the majority of the audience, you know, robotics is probably a little bit taboo outside of the IoT space, right? It's Boston Dynamics, and it's, you know, the guy Rockwell Automation, and folks like that, right?
A lot of, and those are I can't even fathom the expense of some of these things.
Sure.
I know that Boston Dynamics recently said that they're going to make Spot Mini available.
Okay.
I don't think I've seen. I haven't seen any pricing
I'm-
whatsoever. I know for like people that want to go out and buy a robot, there's a few from SoftBank, Pepper and Now, and for the more hobbyist side, there's TurtleBot.
Okay.
Right. There's a few people in this space. But as far as programming goes, Now has their own system. There's ROS, the robot operating system, that's used a lot in.
It's hard to not take that Friends reference though.
Yeah, right. And that's used a lot in academic and industrial spaces.
Okay.
For anybody that's programmed ROS, you have to write drivers pretty quickly, depending on what components they are. So our approach with Misty was trying to give people the ability to use the tools that they're already familiar with.
Okay.
So in this case, you can program Misty in JavaScript.
Okay.
And then we have what we call our API Explorer, which lays out all the functionality that we have, and then you can.
This is on device.
Well, let me take a step back. So there's a few different ways to program Misty itself. There's Blockly, which is block-based programming, basically wrapping our RESTful APIs in a block and giving kids, and frankly, we use it a lot for testing to be able to do this 1,000 times, and I'm going to see how it reacts.
Mm-hmm.
So there's Blockly, and then there's the API Explorer, which is still a RESTful API call, but you get finer grained control over how the robot will react.
But this is still, like you say, API. This is not like
on device.
On device. We're not calling out to some cloud and sending it back down.
No. So this is local on the network. I have the IP address on my robot, and I can send a REST call directly to the robot.
What about other robots? On same network.
So
can I take my RESTful API and go whack robots, whack Jimmy?
I mean, maybe. To be honest, I haven't even thought of that scenario. But the third and the most interesting is really our idea is to give web programmers in particular a language that they're familiar with, and to be able to do interesting things with a physical device.
Okay,
so
fair enough.
You can take these API calls that you as a web developer are very familiar with.
Yeah, you know how that works.
Streaming data from WebSockets and callbacks and the stuff that JavaScript does, and then take all that and load it directly onto the robot. So now the issue of autonomy is now an interesting thing. I'm not a controller and receiver. Mm-hmm. It is on the device.
It's an event loop.
And I can either trigger it, or with Misty 2, we'll have some skill management where you can say, like, start this skill at a certain time, or when the robot's feeling happy, maybe do this dance or something like that.
Is JavaScript really the right language?
Maybe. If our goal is to move the needle with consumer robotics, JavaScript right now is one of the most popular languages. Sure. I had read that Python might have overtaken JavaScript as the most widely used language.
I didn't really ask it.
True or not.
I guess I wasn't asking it from that perspective. It was more of the kind of interaction and ability to do things. And I think about AI, and AI and machine learning seems like a very compelling thing to be inside of Misty Robot's head.
Yes.
And so being able to, have robot drive and recognize other robot and know something that it should do based on that, right?
Yeah. So we are running some, we're running facial recognition locally on the robot, and then we're working on making sure that we can, we can use a TensorFlow model.
Okay.
We don't want to. It is very difficult at the edge to be able to train ML systems.
Sure.
But they become really interesting when you have the ability to get data to train ML systems.
Sure. Yeah.
Especially in the environment that they are operating in.
Yeah.
So that's the interesting use case that we're definitely kind of pursuing.
What is like? All right. So I've got an idea. I start making some stuff. I need to deploy it. What's the development experience look like to from zero to driving into walls?
So obviously idea, right? And then the way that we kind of recommend is you can use our RESTful API. So that way you're sitting at your computer, you can test out the very discrete actions that you want the robot to do. And then using WebSockets, you can see the data coming back in certain ways. And then that enables you kind of broad strokes to be able to get 80% of the way through. So that's still controller receiver. once you kind of get to the point where like, okay, now it has to be performant. I need to make sure that it reacts in certain ways, like when it's running locally. You bundle all of that up using our SDK, and then load that onto the robot, and then we have what's called a skill runner that you can trigger certain skills to run like as you need and start and stop and do all the debug.
Sure.
Anything that uses Wi-Fi, you have a round trip, right? So I'm sending a command, I'm getting data back, and I have to stop the command.
Yep.
So when you put it onto the robot, that goes away. Like
Yep.
It's all.
Yep. Big old event loop.
Yeah.
Yep.
Yeah. So that's where that's kind of the next step in the development process.
Yeah.
And come December, and well, even for our Misty 1 developers, there's certain ways that we're suggesting sharing skills. So hey, this is my Sentry skill.
Yeah.
Here's the code and the assets that are relevant, whether they be sound, visual, or whatever.
Yeah.
Hey, put it up on GitHub or share it, load it onto somebody else's robot, and kind of iterate from there.
So, I mean, obviously in the web space, we're used, or in the node space for sure, we're used to NPM and those types of things. I mean, how does that play in this? I mean, is there a notion of an ecosystem? And you mentioned it a little bit.
Yeah,
but
and we're actively working on it. No, we don't have the full package management to be able to pull all these separate libraries.
Because the semantics are so different. So like, hey, I don't need a package. I'll just use Moment for the date and time. But does that make sense in the context of, robot driving down the thing?
Yeah.
You said performance, and the first thing I think about, okay, well, it's JavaScript.
Yep.
Not that you can't run JavaScript fast, but if I have a time-based thing, maybe that event loop isn't running fast enough against my crappy code in API call land.
So, and now you're hitting so I always think about this is in the digital camera space, right?
Yep.
So you have a point and shoot.
Yep.
You have semi-automatic, and then you have full manual.
Yep.
Right. So what you're talking about is I want to shoot full raw and get all this high, and I want to do all the micro.
But you are targeting developers.
No, we absolutely are. Yeah. So, but I bring this up because for us, it's all right. Let's get people, because I want these types of questions to be able to inform where are those elements where people want to really dig in.
Yeah.
Right. So from every developer's I want raw data. I want raw data. But then when you get down to something like a control system, it's I don't want to write that.
Yeah, I don't want to write it. I didn't want it. Abort.
But yeah, exactly.
Abort.
So come December, and when we release Misty 2, our intention is to try to enable some of that lower level programming.
Sure.
So it runs Windows IoT Core under the hood.
Okay.
So you can write C#, which is a lot faster than running a runtime environment and then a layer on top of that.
Yep.
So we're getting there. We're not there today.
Fair enough.
Yeah.
It's a journey. I get it.
Yeah, definitely.
What's been some of the coolest things you've seen, or most intriguing, if you will?
One of our first hackathons that we had in Boulder, Colorado, somebody tied the robot up to their Domino's account. So when they ordered a pizza, Domino's API has a response that here's how far away your pizza is. So the robot would get more and more excited as the pizza got closer, which I just that cracks me up every single time because I think it's so funny. We've tried to connect it up to a GitHub repository, where when somebody issues a pull request, it'll read the people that can approve that request, and then it will wander around until it recognizes that individual can do it, and then it executes what we call harass.
I like
approve.
Right.
Yeah, right.
That would be a great. You flip that on its side a bit, and if the PR's broke,
yeah,
the robot runs over and electrocutes them.
Have you heard? And I haven't found anybody that's actually seen this work, but GitHub had the blame blimp. This had to have been 2012 that I remember reading about it. But when somebody broke the build, the blame blimp would go and hover over their desk.
That's funny.
So if anybody knows where that came from, I would love to talk to somebody that did that.
we used to just have the police lights, kind of scattered throughout. So if the build broke, the lights would go off.
I like that.
It
That's
was
cool.
pretty obvious. Things were broke at the moment.
But until those are on all the time, and you're like, that's
then you need to start punching some people. Where do kids fit into this? I have to imagine the semantics are a bit hard at that. I mean, I love the raw innocence that a kid brings to pretty much anything, and so in this case, the ideas are limitless. But my 13-year-old or my 12-year-old's not going to bust out some JavaScript and start writing on a robot.
Yeah, and that's why part of the reason why we've had Blockly in these block-based programming is from the beginning. It does enable people that haven't seen themselves as a roboticist.
Sure. I'm going to guess a lot of people don't actually see them.
Well, and to be that even the people that I won't go that far, but but robotics is scary, right? Totally. So you have electrical engineering, you have software engineering, you have firmware engineering, you have mechanical engineering, and then you have to have the wherewithal to keep all that stuff together to make it do a thing,
right?
Which is hard.
Super siloed things in the past.
Yeah.
And now this is all kind of coming together.
Yeah.
This is what we were talking about in the last show, is just this commoditization of all this hardware and software, and the ability to push anywhere creates this new ecosystem that we haven't had before.
It's fascinating. It is. And it's funny because, I mean, there's STEM schools and academies that have taken a very purpose-driven approach to making sure that kids are fluent in programming.
Mm-hmm.
I can go and talk about data structures and if statements and some of the stuff too. Like, I mean, high schoolers now, like most people are at least reasonably aware of that. And so now the next step is, all right, so we have these abstract concepts, and now how does that apply to a robot? Like, all right, so now we're in the computer world, now we're in the physical and the computer world with AI and vision and some of this stuff. But education for us is really, kind of about making that vernacular that roboticists and people in hardware use accessible. Yeah. I mean, one of the biggest problems that a lot of people have is misconceptions about abilities, even with machine learning and AI. It's like, can't you just use AI to solve this problem? It's like, well, we can, but maybe not, whatever.
Right.
So what we want to do, at least at Misty, is provide the ability to take those abstract concepts and see them in the physical world.
Sure.
In the same way that when I'm programming on my mobile device, I have to think about signal strength, battery power, and obviously my phone isn't going to be as powerful as my desktop machine.
Right.
So the same things apply to robots.
Yeah.
There's dead spots. There's certain things that corner situations where I'm reading the same from the optical avoidance,
same
and
distance,
I'm like stuck.
Right.
Yeah. So you end up learning a lot in those scenarios, and so teaching kids what I can't just see an obstacle and turn away from it. There are situations where you see obstacles at both times, or race conditions, and some of these types of things.
Right. What about ethics?
Oh no. So no, I'm laughing just because now it gets hairy and deep. Yeah. Well, especially with self-driving cars. It's like and then
does the robot kill one, or does he kill 100?
Yeah. Or the weapon, and a lot of folks in AI taking the pledge to not make it militarization. That's a word, right? Militarized.
Yes.
AI.
Yeah.
I mean, ethics. But is there an area in ethics with robotics that you're kind of curious about?
No. I just I think we're in this place as software developers and professionals. Like, as this stuff gets commoditized, before in the past we haven't necessarily ethics didn't need to be like priority one.
Yep.
Your piece of the bigger thing was kind of dealt with at a much higher level.
Yeah,
now,
I see what you mean.
Now, ethically, we can control. I shouldn't say ethically. Now we can control drones and this and that, and it's a JavaScript call to a thing, right? We can easily download code to it. I have to imagine at Misty, like, part of the backlog is a category of ethics, and like where do things kind of fit in? Like, are we enabling said thing that
enabling
breaks
bad actors?
Right? Yeah.
I
mean,
Facebook
is going through this, right? Who would have ever thought a social network would have turned into
influential actor? Like, that's
right.
Yeah, and so if you don't have those ethical conversations, then you end up
right. And you're taking that physical world, right? So it probably propagates itself a little higher up.
So I mean, ethically, one of the things that we've always done, we don't want to own data, right?
Sure.
I mean, there's certain usage things that we like. Hey, our motors are burning out. Why is that?
Right.
Okay,
Yeah.
it's because I don't know why it's making 1,000 left turns. I don't know, something like that.
Bad loop.
So there's certain
bad
things
loop
on the feedback of the unit itself that we want to know. But when it comes to things like camera data, microphone data, and some of this other stuff, we don't personally want to, or as an organization, to be able to move that data around. Like, that's kind of up to the individual, the developer. In some situations, you have to be able to do stuff with that data.
Yeah.
So that's why, as a development platform, like you, the owner of the robot, get to decide how to manage that.
Sure.
You know, if you want to use Microsoft Cognitive Services or IBM's Watson to do these things, then that's up to you as the individual. We might provide sample code on how to connect up, but ultimately it's going to be your account that's managing these things. So, you know, we're not taking floor plans and saving them and selling them to, I don't know, IKEA. And if you remember the iRobot, they had talked about, oh, okay, we have all these floor plans of houses because, you know, here's hundreds of thousands of LiDARs in people's homes.
Right.
That didn't go so well.
Right. Yeah, I mean, it's a crazy
but
thing.
you know, ethically, we're doing as much as we possibly can to not encourage hurting other people.
Sure.
Being bad actors in a system. There is a lot of interesting conversations. 3D printers an interesting.
Oh yeah, totally right. 3D printer.
How do you stop somebody from doing that?
Right.
You know, it's in stopping somebody from doing that, then you end up escalating some of the issues with privacy.
Right.
And so it's a very difficult thing.
Yep.
So, yeah, and the whole reason Apple's trying to stop people from, or they don't want to have a back door.
Right. Yep.
That's
fair.
It's, man, I don't have a good answer.
Right.
For these types of issues.
No, it's just one of those things where we have to, like, those are things that need to be talked about, right? And that's 20 years ago. It wasn't, you know, it's just the commoditization of this stuff as it comes down lower. Forces that to go higher.
And to be kind of devil's advocate, you remember when they started adding cameras to cell phones?
Yep.
You remember
it
was like, this is the end of privacy.
Yep.
You can't even go into a locker room or whatever the case is, and then people were like banning them from certain places. And you know, I remember at the time like kind of agreeing with some of the stuff, like, oh my gosh, like people can take pictures anywhere.
Yep.
But then when it really came down, the value add was so much better to have a good camera with you
absolutely.
at all time.
Yep.
That's like, okay, yeah, but that's
but
where
at the same token, right? You're here at that conference, and we have to legally have signs up that say you forgo your rights because you came into this space. So if we take a picture and we use it in any shape, way, or form,
I missed that one. No, I'm just kidding.
Doesn't matter. It's there.
It's there. No, just kidding.
But like that was a aha moment for us at one point. And then when we, you know, a few years ago, we had some guys taking just some videos of the water park and whatnot. We also had to make sure that the people, patrons, whatnot, who are in the water park wanted to even be filmed, because now you have another level of personal privacy, if you will, right? You know, but drones, right? Drones fall into the same thing. It's a touchy thing.
I think over the next few years, there's going to be an interesting conversation between, you know, the rights of the individual and then the rights of corporations and then the rights of, you know, just being in a public space.
Right.
I mean, have you talked about GDPR yet?
And it was nice talking.
Hey,
we're
now
out.
Everybody's gone. But I mean, these are conversations people are having, like the whole Google Maps thing. Like, what are you as an individual allowed to the rights of privacy? And then, if I'm bringing these things into the home, what rights does the service?
Remember when it was just about email and getting it searched by Google?
Yeah,
it's got a lot harder.
Oh, the halcyon days.
Yes. All right, Chris. Well, let me wrap this with the question that I ask everybody, and maybe yours will be robotic in nature. But at the end of every Ask That, I ask, what does community mean to you? And since you're in charge of the developer experience and this stuff, I'm curious, what does community mean to you?
Okay, let me. I'll have the great answer, but give me 1 second to actually see how to articulate it. I mean, community is so multifaceted, right? I mean, from my perspective, community is really about taking a shared goal or movement, right? And being able to be around those people that share that idea. I see robotics as such a positive potential for humanity and for people and for individuals, and being able to drive that forward and be able to bring different perspectives to the mix. That is the community that I want to be a part of and cultivate. Yeah. But then even in the broader sense, it's just the common good. my neighborhood is about taking care of our neighborhood. Boulder is a wonderful place for startups because Techstars and some of these other organizations, like, it's give first. What can I do for you?
Yeah.
That ends up propelling everybody forward.
Sure.
So maybe the one-liner would be community is moving things forward in a positive direction.
Love it. Love it. Before we go, how can people find out more about either you, Misty Robots? Where do they go?
Well, MistyRobotics.com has all the stuff on our Misty 1 Developer Edition and Misty 2, which is coming out in December, and then our second batch coming out in February. And then, I don't know, me personally, just Chris Meyer.
And what?
Meyer the Meyer on Twitter. I don't know. Like, hey.
And what's the name of y'all's like showcase robot? I'm sure you have some name for it.
Misty 2?
No. I mean, like, do you call it Jim, Jane? It's got to have some like unmarketing name.
We did this very deliberately. So if you have another 20 minutes, I can explain the whole hierarchy is like why we're named Misty. But it is Misty. It's Misty.
Okay.
Yeah.
All right. Fair enough. All right. All right. With that, then I ask all of you watching, how do you think about robotics? What are you doing? Have you thought about it? I don't know what.
And then add me to the conversation.
Yeah, absolutely. That physical piece in the world is super interesting. So
yeah, physicality plays an enormous. It has an enormous impact on the way that people perceive electronics.
Sure.
And personality and those types of things. So it's fascinating.
Totally. Well, Chris, thank you for
Hey, it was
being
my pleasure.
on.
That was fun. We'll get into GDPR next time.
All right, that sounds good. Thank you for watching. We'll see you next time.